We shall now look at a special geometric series with first term a equal to 1, r equal to x. Previously, we know that sum to infinity of a geometric series is a over 1 minus r under the condition r must be between -1 and 1. So we consider this special geometric series with first term 1 r equal to x, and we take the sum s equal to 1 plus x squared, x cubed, x power 4, and so on, under the condition x between -1 and 1. So we can talk about sum to infinity, which is a over 1 minus r. And you substitute a as 1, r as x, to get 1 over 1 minus x. And we can find the sum of 1 plus x squared, x cubed, x power 4 using a method 2. Now what I did for recurring decimal. So you start with s equal to 1 plus x squared, x cubed, and so on. And you multiply the whole equation by x. If you multiply the whole equation by x, then what you have will be, from 1 you become x will become x squared become x cubed, and so on. And then you subtract the two equations. So you can call this equation 1, this equation 2. And then you subtract the two equations. Left hand side will be s minus xs, right? On the right hand side, x and x cancel, x squared cancel, x cubed cancel, everything cancel away except the number 1. And after that, you just do a factorization. Take out s. So it's s into 1 minus x equal to 1. So you get s is 1 over 1 minus x. And this is a very useful result. This result, s equal to 1 plus x squared, x cubed, x power 4, and so on. This is a very useful result. And later when you do binomial expansion, in the later part of this chapter, right, you'll find this is very useful in doing expansion. And you take note that it's under the condition x between -1 and 1. Let's try to put some numbers and see what result will you get. Let's go to the first example here. So I call this example A. Let's do example A. 1 plus 1/3 plus 1/3 square, 1/3 cube, and so on. So A is actually 1, right? The r is 1/3. Or you can take it as x is 1/3. If you take it as you're looking at 1 plus x squared, x cubed, x power 4, then you just take x as 1/3. So the sum should be 1 over 1 minus x. So which means you put x as 1/3. If you put x as 1/3, eventually it simplifies to 3 over 2. So which means if you add 1 plus 1/3, 1/3 square, 1/3 cube, and so on, eventually, no matter how many terms you add, you get 3 over 2 as the answer. Okay, let's try to look at the second one, part B. It's 1, 2, 4, 8, and so on. So you keep multiplying by 2, right? So it's like you take x as 2. So if you try to apply this formula, s is 1 over 1 minus x, by substituting x as 2. So if you try to look at part B and take it as is of the form 1 plus x squared, x cubed, x power 4, and so on, with x equals to 2, and you sub inside the right hand side, it gives you -1, because denominator you sub x as 2, you get -1. 1 minus 2 is -1. You get a wrong answer. So why the answer is wrong? The answer is wrong because you choose x equal to 2, which is not between -1 and 1. So in order to apply this formula, s equal to 1 plus x squared, x cubed, x power 4 equal to 1 over 1 minus x. So in order to apply this formula, you really have to keep x between -1 and 1. Otherwise, the formula will give you a wrong answer.